Okay, I will make up some time. My name is Kai. I work on wearable electronic textile for healthcare application. I'm going to talk to a project. One is for the stroke rehabilitation. One is for the physical health monitoring. Both are funded there. One is 2122, one is 2223. So before I start to work about my research, my research focuses on developing new material manufacture methods for the application for healthcare. So in other words, how to make the clothing we are wearing more intelligent, smart use days, which normal clothing can't do. So two of examples will be, one is the one going to present, one is stroke rehabilitation, one is health monitoring. So apart from the material manufactured healthcare, along the whole process, what we also consider is about the sustainability, how we minimize impact to the environment while deliver the social benefit of this technology. And the last one is commercialization. Once commercialization is not purely about kind of how to make money. It's more like how we make the process is relevant to the final production scale up to make what we develop is commercially viable and relevant. For example, how to make it easier for people to access. So unless people have code one of those, they can't get the benefit. So that's our kind of for aim. Area of research. So for two projects, I'm going to follow the same outline. I will talk about what is the rationale, why we do this project, what have we done with the project, what is the outcome, and where it leads us to. So first is smart textile with integrated functional electrical stimulation for stroke rehabilitation. So stroke. Stroke is the leading cause of adult disability. It leads to death, disability, and cost to the family and society. So in the UK, there's 1.2 million stroke survivors, cost society a lot of money. Stroke affects the function, many parts of the body, as you can see there, and the movement disability is one of the main disability which caused by stroke. But the good thing is, we all know if we want to learn some activity, especially the physical activity, like any sports, we just practice, because we know if we practice more, if we practice very accurate, intensive, we will get better. It's for the same for the stroke. And for those who got lost the movement ability, if they can practice, they can eventually gain if the brain still can build the link, which is damaged during the stroke. But because they can't move their, let's say, arm for this particular case and the hand, they can't practice. The functional electric stimulation I'm going to refer to. FES is a technology got two electrodes placed on the skin. One is connected to the electronic control unit. It will deliver current through the skin to activate the muscles to stimulate the motor nerve to generate artificial movement. So the more they practice, they build the muscle strength at the same time. It's rebuild the new link in the brain, which is the neural link to perform the daily movement functions. The problem with that is electrode planation is crucial, but stroke survivor, we talk to them, find it's really struggle. They don't know where is the right place. Even with their family member, they are very struggle. So with all those complications, they just decide I'm not going to use it, I'm not going to use it. So in this project, we aiming to develop a textile base which allows stroke survivor to use it independently at home. So that is the aim. In order to make that happen, what we need to do is, because this is a very close code developer with a stroke survivor, we need to get an ethical approval, and so that is for engagement co-design with the end user. The other part is about the design. As I said, we are aiming to develop this sleeve, which looks like a normal wearable clothing, but got those electrode embedded to replace sticky hydrogel used. It has nice techniques, which means you can move around while it still have good contact with the skin, and also people can just pull on by themselves, find where is the right place. And so we spent a lot of time on the design and also the manufacture. What yarn, what textile do we use? What structure? Which parts should be kind of more tight compressed? Which parts should be more loose? So that is the streaming activity. What we didn't get the opportunity to do because this is during COVID, which the restrictions still was in place. We can't get the stroke survivor come in. Is a prototype test and refinement. And so in that project, we identify the textile material and the structure. We work with the end user, maybe on June, so we are familiar with that, to validate the idea, identify what is their unmet needs, and we build partnership with industry to do the fabrication process, and we work closely with a local charity, which is a stroke, different stroke Southampton. We got some, we've got 2 papers published, which is based on the design, on the manufacture, and the early prototype of the test. So what I didn't stop us to do is after that project, we got this prototype when the restriction is really lit up, we got the end user come to the mock test. And because we have this safe funding, we work with industry partners to do the manufacture. When later on they decided they are going to apply for the innovative funding, and they teamed up with us because otherwise we are not eligible, because we can't lead the application, it got to be company led. So through our collaboration, we partnered with them continuous on the innovative project, which means extra income, extra work, extra progress in the project. And with that project, we solved some technical challenge, which did not only this project, but also other benefit of other projects. And we finally got the prototype. We went through many iterations, more than 10, which finally we got one. A stroke survivor can use it by themselves. They can put on, take off. He can put the connector to control the stimulation level, as you can see. Normally, stroke got a kind of close locked hands, but with the stimulation, it allows him to do the exercise. Which to normal people, it's extremely simple activity, but to them, yeah, he's so excited because he suddenly hasn't been able to do it for many years. His wife was so kind of nearly in tears when she saw finally there's a kind of movement in daily rather than kind of physiotherapy type. So that is this project. What we are going to do next is a lot of time we are really good at research, but what we're not good at is promoting the work. You can't get a kind of very beautiful, nice image, especially for me because it's kind of engineering approach or it's this public prototype. So we are going to hopefully get some nice filming picture to do a short video. And because we demonstrate the unmet, we engage with the end user, there's unmet needs, which our technology can fix, solve the problem, and also we have to demonstrate the capability and feasibility for the technology side, the next step is we're going to apply funding to develop a product and to do some home usability test before do the clinical trial. And of course, as I said, we apply this technology to other applications, which will open doors to many new areas. So that is the first one. It's kind of courtesy funding, so that it leads to further collaboration, further development, and will lead us to the next stage.